Okay, let me briefly talk about Bayes' theorem. It's just pretty simple formula. That's a governing formula, which is the probability of A happening given B. There, the bar means given is equals to the probability of B given A multiplied by probability of A divided by probability of B. The jargon is where I think it is worth mentioning is posterior. This is called posterior, this is called likelihood, this is called prior, this is called evidence. So a way to intuitively understand it is like the likelihood of this is multiplied by the prior belief, and then divided by the normalization, and then you got posterior. So the posterior is updated belief. Likelihood is if you're given, say, a given coin, like what's likelihood of head and head, and then the prior is like what you believe going in, and here are some good formulas that you may find useful. Is PBA and PAB is effectively can be understood as a AB union, A and B, namely as in the Venn diagram is just like the intersect. So the PAB can be expressed as PAB over B. You can intuitively understanding it as this is a possibility sample space of the probability space of A and probability space of B, and then intersect here marked as red. So this effectively is a ratio of the red over the blue, which is the entire space of B. You can imagine it is just, A and the place where A and B both happened, and then divided by the B happened, then it become the probability of A happen given the B. So here are some more important formulas. Is PB is sum of PB given X, where X is a full set of like that means like quote, I think disjoint union. This thing is called disjoint union. So meaning is union that does not have an overlap. So each one of them is not overlapping, but they cover the entire probability space. So it's very intuitive to understand as, given this is sum of given one of the subspace B happen, given another subspace B happen, and then all the possible subspace scenarios then B happen, then it's the total probability of B happen. Another good formula is Pi when the probability of Px x1, 2, 3, n all happen is end. The comma means end. They all happen at the same time is Px1, and then this is meaning like multiply together from n 2 to n is P given xi given x1 to I minus 1 happened. So put it into this can be expanded very long to put in a very simple terms. Say a probability of ABC both happen is probability of A multiplied by B given A, and then C given AB. You can imagine it's almost like a recursion. It's like this is effectively AB union. So it's AB, and then this multiplied by this, then there will be ABC. So this thus given this formula. So I wanted to make a little bit a more important. There's another important formula. You can derive effectively anything from this. Using base theorem to derive using other simple relations. But let's just look at an example. So I think I'm gonna change the video format to jargon, formula, intuition, and examples. So I guess, where is it? Oh, there we go. So factory A and B make chips. A makes 80% of total chip. B makes 20% of chips. And A has a defect, chance of 1% of defect. B have a chance of defect of 5%. So ask, what is probability of you got a chip, this defect, it is B. So this, given its defect, the chip is B. So let's first translate these into, translate English into actual probability. So this, let me use RAM. This PA equals 0.8. So like the 20, if you just have a pool of chips, the probability to draw a random one, the chip 80% of chance is a chip made from an A factory. Similarly, PB is 0.2. And just to make it useful, and then you can imagine those who come, this is already, it's implicit, but I think I would like to mention it, is the disjoint union is a full set because they make 100% of the total chip. A lot of time you ignore it, just assume it, but it's good. You can add it there. Defective is basically this defective given it is chip A is 0.001. Similarly, defective given B is 0.005. Using our formula, it will be PDB PB divided by PD. So we have this, we have this, we don't have this. So remember the formula we had is PD, all the possible sub-scenarios is given B plus PA given A. And then you will have PB, PB, and then you plug in the number. Now you have all the four numbers here. you have 0.005, maybe 0.2, 0.005, 0.001, 0.8. You multiply by 1,000 on both sides. Then you have 5 multiplied by 2, 5 multiplied by 2 plus 1 multiplied by 8, which is 10 over 18, which is 9 over 5. And let me double check my math. Yeah, there we go. And there you go. That's one of the most standard and most commonly seen problem you will see. And just sometimes you need to keep in mind like this condition sometimes is not met, and sometimes you need to see if they're independent or not, and to see their union. Because at the end of the day, the most important picture you want to see is this. This is a picture. If you look at it in the Venn diagram standpoint on the probability space, it's much more intuitive.